Self-driving cars can navigate without human input using sensors to detect their environment. They can steer autonomously, avoid obstacles, and obey speed limits. Early concepts date back to Leonardo da Vinci, but significant advances include cruise control in the 1940s and adding cameras/computers to detect objects in the 1980s. Modern versions use technologies like lasers, cameras, radars, and ultrasonics along with GPS and highly detailed maps to locate themselves and monitor surroundings. Potential benefits include fewer accidents, reduced injuries, less traffic and fuel used, and lower transportation costs. Introduction: Self-driving cars are the future of smart transformation. To begin, a self-driving car is a vehicle that is capable of sensing its environment and navigating without human input. Self-driving cars can detect environments using a variety of techniques. It can steer itself while looking out for obstacles and accelerate itself to the correct speed limit. History: 1500 centuries before the invention of the automobile, Leonardo da Vinci designed a cart that could move without being pushed or pulled. 1945 An engineer became so fed up with the rocking motion he experienced while riding in a car with his attorney behind the wheel that he developed one of the first cruise control system to smooth out the ride, using a mechanical throttle that could set the vehicle's speed. The invention was commercialized in 1958. 1987 Another important step forward in autonomous tech came from German engineer Ernst Dickmanns, who equipped a sedan with a bank of cameras and 60 microprocessing modules to detect objects on the road. 2015 The most significant aspect of Tesla's semi-autonomous autopilot feature, introduced in late 2015, which enabled hands-free control for highway and freeway driving. This image provides a brief timeline of the history of autonomous vehicle development, particularly focusing on the contributions of Sebastian Thrun and the Google self-driving car project. Current, 2015 Sebastian Thrun, the director of the Stanford Artificial Intelligence Laboratory and co-inventor of Google Street View, was leading Google's self-driving car project. Thrun is a key figure in the development of autonomous vehicles. Past, 2005 Thrun's team created a robotic vehicle named Stanley, which won the 2005 DARPA Grand Challenge. The challenge was a major milestone in autonomous vehicle technology, and the victory came with a $2 million prize from the United States Department of Defense, DoD. 2011, the state of Nevada became a pioneer in autonomous vehicle legislation, passing a law on June 29, 2011, that paved the way for self-driving cars on public roads. 2012, March 1. This law came into effect on March 1, 2012, when the Nevada Department of Motor Vehicles issued the first license for a self-driven car in May 2012. 2012, Toyota Prius, the first vehicle to be licensed as a self-driving car was a Toyota Prius, marking an important step in the commercial and legal adoption of autonomous vehicles. This timeline highlights the early breakthroughs and regulatory progress that contributed to the development of autonomous driving technology. This image illustrates the key technologies used in an autonomous vehicle to navigate and make real-time decisions. Here's a breakdown of the components highlighted in the image. Laser sensor, LiDAR. A laser sensor mounted on the vehicle scans 360 degrees around the vehicle to detect objects, providing the car with a detailed map of its surroundings. This sensor is critical for detecting obstacles and mapping the environment. Processor. The processor reads the data collected from various sensors and regulates the vehicle's behavior. It makes decisions based on input from the sensors, such as adjusting speed, turning, or stopping. Radar. Radar systems measure the speed of vehicles ahead. This helps the autonomous vehicle maintain a safe distance from other cars and react to changes in traffic flow. Orientation sensor. This sensor tracks the car's motion and balance, ensuring that the vehicle remains stable and follows the desired path. Wheel hub sensor. The wheel hub sensor detects the number of rotations of the wheels, which helps the system determine the car's exact location and track its movement. Together, these technologies enable the vehicle to drive autonomously by constantly sensing its environment and making decisions to ensure safe and efficient travel. Some technologies which used in self-driving car: laser rangefinder, front camera, bump-mounted radars. Aerial ultrasonic sensors. Working of self-driving car uses a combination of sensors and software to locate itself in the real world combined with highly accurate digital maps. Like a satellite navigation system, GPS is used in self-driving cars for exact position, at which point radar, laser, and cameras take over to monitor the world around the car. The software can recognize objects, cars, road marking, and it allow multiple unpredictable hazards. The Google Potential Annual Benefits Aspiration refers to the company's ambitious goals in terms of applying AI and other innovative technologies to maximize impact, both for the organization and for society as a whole. This aspiration includes leveraging AI to make significant advancements in fields such as autonomous vehicles, e.g. Waymo, scientific discovery, and quantum computing, while also ensuring the technology benefits billions of people globally. Benefits. Google's Potential Annual Benefits Aspiration, US only, reduction in 5 million fewer accidents, 2 million fewer injuries, reduction 4.8 billion fewer commuting hours wasted, 1.9 billion gallons in fuel saving, commuting, reduction in car, reduce cost, trip per mile, increases car utilization, better land use. This image showcases a conceptual self-driving car and highlights its key safety and functional features. Sensors for self-driving. The car is equipped with sensors that allow it to navigate autonomously, detecting the environment, obstacles, and making real-time driving decisions. Seating for 2 passengers. The vehicle is designed to accommodate 2 passengers, indicating that it's a small, urban-style car likely intended for short trips. Buttons for start/pullover and emergency stop. The control interface is simplified, providing buttons that allow passengers to start, stop, or pull over the vehicle, enhancing user control in critical situations. Safety measures. The car uses a flexible windscreen and foam-like materials, which are designed to minimize injury in case of collisions, making it a safer option in urban environments. Speed limit. The maximum speed of the car is limited to 25 miles per hour, 40 kilometers per hour, indicating it is intended for city driving or areas where high speeds aren't necessary. This design suggests a focus on urban mobility, safety, and ease of use, showcasing what an early model of a fully autonomous, user-friendly vehicle might look like.